This is part 4 of polar equation of conics. Okay, so here is another example. 10 over 2 plus 3 sine theta. Now if you look carefully, we have plus sine. So going back to this right here, since it is plus, face down. Okay, since it is plus, face down. Okay, if it was minus, then face up. Okay, so again, this is plus sine, face down. Okay, so same rule apply. We need this 2 to be a 1. We need this 2 to be a 1. So whatever that number is, divide by it. So if this was 5, divide by 5. If this was 11, divide by 11, and so on. Here it is 2, so divide by 2. So 10 divided by 2, 2 divided by 2, 3 sine theta divided by 2. To all of them, okay? All the terms, divide by 2. So 10 divided by 2 gives me 5, 2 divided by 2 gives me 1, 3 over 2, just leave that alone, okay? So now this is a 1. Right here is my E. This is my E right here. So E is 3 over 2. Since it is bigger than 1, it is hyperbola. Okay? And again, E is bigger than 1, it is hyperbola. And since this is a plus, if you look carefully, this is a plus, face down. So one of them will face down, and then you have the other on top. So this will be a vertical hyperbola. One more time. This is plus sine. So plus sine. Okay. It's face down. So one of them will face down. And since this is a hyperbola, the other will face up. Okay. So here's a preview of the graph. So how do we get this graph? Again, plus sine. One of them is face down. And because this is hyperbola, if one of them is face down, the other must face up. Okay. All right. So this is E. So E is here. Okay. Now we need to find our ED. So ED is right here. This is our ED. Make it equal to 5. Put E in, which is 3 over 2. Bring the 2 over. That gives me 10. Divide by 3. So the distance from the dielectric to the pole is 10 over 3, which is about 3.3333. Okay, so here is the dielectric from here to here. So the distance from this line right here to this pole is 10 over 3, which is 3.333. Okay. All right, next we need to use these degrees to find our points. Okay, so again, use 0, 90, 180, 270. Plug it into the original equation, which is here. Here's our original equation. Okay, so put 0 in, sine 0, you know it is 0. 0 times 3 is just 3. 0 times 3 is just 0. Again, put 0 in, sine 0 is 0. 0 times 3 is 0. 2 plus 0 gives me 2. 10 divided by 2, 5. And so on. Okay? But if you look very carefully, when you got to 270, it came out to be negative 10. Now, with R, if you remember, in polar form, R is always positive. Okay? Same thing with rectangular. R is always positive. Okay? So, because this is negative 10, it's going to be reverse. Why is it reverse? According to this, we have one of them face down. Okay, and since it is hyperbola, the other side must be on top. So therefore, this negative 10 will be positive 10 here. Okay, so plug this in. 0, 5. Here's 0, 5. 90 degrees and 2, which is here. 180 degree 5, which is over here. Okay, but this is negative 10. So because this is a hyperbola, one of the side is already face down, so the other has to be on top. So therefore, this negative 10 is not negative 10. It should be up here, positive 10. Okay, so right here is 270, 10. Again, R must be positive. So because one of the graph is already face down. And just by looking at this, you know that this is vertical. So therefore, the other side must be on top of this. So instead of negative 10, positive 10, which is right here. Okay, so that's what a rough sketch of what a hyperbola is according to this equation. So this equation is this. Okay, now hyperbola has two focus, one right here and one on the other side, which is over here. Okay, so focus is here and the other side would be over here. Okay, so so the focus should be up here. Here's the focus, should be right here. This point is 270 degree 10. This point right here is 270 10. The focus should be right here. The other focus should be right there. Okay, so that focus, which should be right there. Okay, now how do I know that is right there? If you look at the bottom graph, the bottom half of the graph, from this vertex to here is only 2 units. So therefore, from this vertex up, also 2 units. Okay, so again, this vertex to here is 2 units. So this vertex up should be also 2 units. So the other focus should be up here. Okay, now how do I get the center? How do I get the center between this vertex and this vertex? All you have to do is just take 10 plus 2 and then divide by 2. One more time. 10 plus 2 divide by 2. So that gives me 6. So our vertex is 0, 6. Okay. One more time. How do I get the center? How do I get the center? Take this vertex, which is 10. Take this vertex, which is 2. 10 plus 2 gives me 12. And then divide by 2, which is the average. So 0, 6. So right here is our center of the hyperbola. Right here. Okay, 0, 6. Okay, now how do I get this point and this point? So if you look very carefully, from our focus out is 5. From focus out that way is also 5 units. Okay, so go up to, which is our second focus, 5 out this way and 5 out that way. Okay, so again, how do I get this point as my second focus? If you look very carefully at the bottom half, from this vertex here is 2 units. So that's our first focus. So from this point up should be your second focus. Okay, 2 units up. All right, so that's how I find my center. Okay, now to get A, which is my major axis. Now here, if you remember in previous video, if this is vertical, then from here to here will be my major axis. And then from here to here will be my minor. Okay, so be very careful. If it's horizontal, then my major would be horizontal. If it's vertical, then this will be my major axis. Okay, so with hyperbola, your major axis is still 2a. Okay, your major axis is still 2a. But how do I get this number? 10 subtract 2. Take this point right here. 10 subtract 2. Okay, so 10 subtract 2 gives me 8. Divide by 2 gives me 4. So from the center, if you look very carefully, from the center to this vertex is 4 units. So count 1, 2, 3, 4. Going up, same thing. 1, 2, 3, 4. Okay, so that is A right here. From here to here is A. From this distance right here, from the center to here is 4. From here to here is also 4. Okay, so that's how I find A. Now let's find C. Again, this formula right here is only for hyperbola and ellipse. Okay, so one more time. This formula is only for hyperbola and ellipse. We know what E is, 3 over 2. Where did I get this number? Up here. Okay. And we know what A is, which is 4. Okay. So cross multiply. 3 times 4 is 12. 2 times C is just 2C. Divide by 2. C is 6. Okay. So where is this C? If you remember, C is always from the center to the focus. Center to the focus. So count 1, 2, 3, 4, 5, 6. Going up 1, 2, 3, 4, 5, 6. Okay, so again, C is the distance from the center to the focus. Center to the focus. Okay, now with B in hyperbola, we use this formula. Okay, now if you remember in ellipse, this was minus. This was minus. But with hyperbola, this is plus. Okay. And we want to find B. So all we have to do is just move A over. Move this A square over. So it becomes minus A. We know what C is, 6. We know what A is, 4. So 36. 16. So 36 subtract 16 is 20. We don't want square, we want the square root. So square root 20 is square root 4, square root 5. Square root 4 is 2. Square root 5 is below. So B is 2 square root 5. Okay, so what is B? What is the distance of B? Where is that on the graph? So distance of B is from the center to the right, center to the left. Okay, so distance of A, so we know that A is 4. So A is from here to here. From here to here is A. Distance of C is from the center to the focus. Distance of B is from the center, somewhere out here at 2 square root negative 5. Okay, so from here out here. Okay, so that is the graph, rough sketch of this equation. Graph this equation to this graph. Okay, and how to find A, C, and B. Okay, how to use this so that I can graph. Be very careful because we are in hyperbola. The bottom half is here, but this is negative 10. So it cannot be down here anymore. It has to be face up. Okay, so it has to be flip up. Okay, so be very careful of this negative. Okay, in hyperbola. Okay, same thing. If this was horizontal, this negative 10 cannot be over here. It has to be over this side. So be very careful of that. Okay, again, R is always positive, okay, in polar and rectangular. So be very careful of that. Okay, so let me zoom out. Okay. Now use this information to convert polar equation. Use this information, all this right here, the A, the C, and the B, to convert this into convert polar equation into rectangular. Okay, so here we go. Now with hyperbola, you have two equations, one for horizontal, one for vertical. This is for horizontal, this is for vertical. Now if you look very carefully, horizontal, X goes first. Vertical, Y go first. However, if you remember, in ellipse, this is supposed to be plus. In ellipse, this is plus, but with hyperbola, this is minus. Okay, so X minus horizontal, Y minus vertical. Okay, so this formula is for hyperbola. Horizontal is when X goes first, vertical when Y goes first. Okay, with hyperbola, this is supposed to be minus. If this was plus, then it is ellipse. Okay. So we have all this information already. We know what C, we know what center is 0, 6. We know what A, we know what B is, which is from here. So here's my A, here's my B. Okay, all you have to do is just plug them in. So my center, again, this is your H. Okay, this H, this is for K. So because just by the graph, we are going to use vertical. So vertical, we're using this formula right here. Okay, so here's your K, 6. Here's your H, 0. Okay, A, we know that it is 4. Okay, right here, A is 4. So 4 squared. We know what B is, 2 square root 5. Okay, so plug them in. So 4 squared, that's where the 16 is. So A, you know that is 4. B, it is 2 square root 5. Okay, so put 4 in here, square it, becomes 16. Put B in. Now square 2 square root 5. Okay, so if you remember the algebra, 2 square root 5 square, distribute the square, so that gives me 2 squared, square root 5 squared, so 2 squared will be 4. Square root and square cancels out. I just have 5, so 4 times 5, 20. Okay, so this is the equation in rectangular form. This is the equation for polar form. This equation and this equation are the same graph. It's just written in different form. One more time. Polar equation, rectangular equation. It is the same graph, just different way of writing the equation. Okay, so I hope. So let me go on to the next one. But before I move on, make sure you know how to convert polar into rectangular. Okay, and be very careful which one you're using, horizontal or vertical. Okay, now I hope this graph right here will help you to see a little bit better in the next page, where the graph is more precise and accurate so that you can see. So as you can see, here we go. This graph is this, but better. Okay, so here is my vertex. Okay, 0, 2. Okay, all right, here's my other point, 5, 0. Okay, so here it is. If you look at this chart right here, 0, 5, 0 degree 5, which is here. 90 degree 2, which is here. 185, which is here. 270, negative 10. However, because this is vertical, half of this is already face down, so the other half must face up. So that's where 270, 10 is right here. 270, 10 is right here. Okay. One of my focus is here, so the other focus must be up here. If you look very carefully, from here to here, that is 2 units. So from this vertex to here is 2 units. So same thing, from here to here is my other focus. Okay, so here's my A. From center to this vertex is A unit, which is 4. B, center to the right or to the left, same thing, which is 2 radical. Okay, 2 radical 5, sorry. So this should be a 5. Okay, so that should be a 5. Okay, all right. So, and the reason is right over here, I just, instead of writing a 5, I wrote a 2. Okay, so it should be 2 radical 5. Okay, so 2 radical 5. And then distance C from center to the pole axis. So center to the pole axis, which is here, 6. Okay, so distance A, distance B, distance C. And there's my directric at 3.33333. Okay, so this is rectangular form, polar form. Same graph, just different equations, different form of writing the equation. Okay, so rectangular, polar. Here's rectangular equations, polar equations. Same graph, different way of writing. Okay, so let me zoom out so you can see the whole thing.